சொல்லணும்.
Sir, I had joined, sir.
Madam, good afternoon. I made you as a host.
Yes, sir. I saw, sir. Thank you, sir. I'll be the recording is on.
Now you can switch off the recording after the meeting starts. You can switch on also.
You just pause the recording.
You can, if I made it is on only, you can control all these things, right? Hello. You are in mute, madam. Hear me? Hello.
Sir, I had joined, sir. Yeah, thank you.
Fine.
Yeah, sir. I'll take
You
the
can pause the recording. You can pause the recording now.
Sure.
Fine, madam. Fine, but you can control.
Sir, I had joined, sir. I'll do the recording, sir.
Yeah, please wait. It's already recording is going on, madam. You can pause it now.
Yeah, I'll do,
later-
sir. I'll connect to the system. Are you leaving right now?
Fine, fine.
Okay, sir. Thank you.
Pardon?
You.
No, I'll be there. I'll be
I'll
there.
take care.
Yeah, please. You can pause the recording now. Later, you can switch on. Again, you can
Yes, sir. Sure,
continue that also. Fine, madam. Fine, madam.
Yes, sir.
Thank you.
Sure, sir. Sure. Thank you. Sherry ma'am, I made you co-host.
Hema?
Yes, Sherry ma'am, I'm going to the department. No co-host ஆகிருக்கேன் பாருங்க. நீங்க co-host. Hello?
Yes, Hema. Yes, Hema.
நீங்க co-host இதோ வந்துறேன். சிஸ்டம்ல போய் join பண்ணிடுறேன். I'll join from the system, department system.
Yes, Hema. Yeah. Hema?
Yes, ma'am. Yes, ma'am.
I'm here, Hema. Yeah, you want. Yeah.
Hey, go ahead.
A very good afternoon and welcome you all for the second day session of this national webinar. We'll begin this program with a prayer. May I now request Ms. Anjali Rahe, Assistant Professor, Department of Physics and Coordinator, Center for Environmental Studies, to lead us in prayer. Anjali?
Sorry, ma'am. Yes, shall we all bow down our heads in prayer? Our Father in heaven, we thank you, Lord, for this opportunity you've given us to meet through this Zoom platform, to learn about your creation, about nature and how to take care of it, Father. We thank you for all the flora and fauna that you have gifted us with, and you have called it good. We pray that you give us the wisdom to teach and to learn about this nature that you have gifted us, to take care of it for our good and for your glory. We submit this session into your hands. We pray that you will give us all wisdom to learn as much as we can and to put it into practice. We thank you once again for this opportunity you've given us. In Jesus' name we pray.
Thank you, Anjali. May now invite Dr. Bhavani to come the gathering and introduce the speaker for the day.
Okay, thank you, Sherry.
Over to Bhavani, ma'am.
Good afternoon, friends. On behalf of IFTR and the Center for Environmental Studies, Women's Christian College, Chennai, I extend a very warm welcome to our distinguished speaker, Mr. Jagadeesh Sunkad, and all the participants of today's program on aeroponics. Special thanks to our speaker for accepting our invitation with a very short notice. Now, a few words about our speaker. Mr. Jagadeesh strongly believes that science and commerce of agriculture needs to work in coordination for any meaningful impact. He identified his life's purpose to build a scalable business by carefully nurturing innovation and trained himself to impact the lives of small farmers at the grassroots level through technology commercialization. Mr. Jagadeesh Sunkad is presently working as Chief Operating Officer, SAM Agrobiotech, and he has professional experience of 32 years in agribusiness field, encompassing innovation management, contract farming, technology transfer, research and training, market research for customer satisfaction. After graduating in electronics, Mr. Jagadeesh continued his education in management at Cornell University, United States of America, and Indian Institute of Management, Bangalore. With his profound knowledge and technical expertise, Mr. Jagadeesh Sunkad made notable contributions in public domain. To mention a few, by setting up aeroponics for seed potato microtuber production, introduced hydrogel, a soil conditioner for slow release of water and nutrients, started value chain development initiatives for building market linkages, introduction of sugar beet cultivation in South India, vacuum packaging with jumbo bags for export of red chilies, introduced wide row planting of sugarcane, development of pharma grade papain enzyme from papaya, and he is a member of founding team for KLE Society of Agricultural Training and Research, Belgaum, and he pioneered export of cut frozen vegetables from Belgaum, organized contract farming for vegetables, wheat, barley, red chilies, potatoes, breeder seed multiplication. Mr. Jagadeesh offers consultancy in various fields, again to mention a few, assembling a team of multidisciplinary experts, willing and competent at the new possibilities, writing and building a policy environment for the project, competition analysis, IP protection, building prototype business models, pricing and go-to-market strategies, investor education, building collaboration and joint ventures, design turnkey projects, offering support from start to the end till the project is handed over. And he is the key resource person and mentor for Rashtriya Krishi Vikas Yojana, RKVY, at Indian Agricultural Research Institute, New Delhi, and National Institute of Epidemiology and Disease, Bangalore. Besides all this, he finds time to build ship models, teach, coach, and mentor startups in the field of agriculture. Sir, we are fortunate to have you with us today, and may now request you to deliver your talk on aeroponics. Thank you so much, sir.
Thank you so much, ma'am. It's an honor to be with students. We feel younger, we learn a lot with them. Okay. Thank you for the generous introduction. And students, one of the things that got me to agree to this event is at the background to the title of aeroponics and hydroponics is the idea of entrepreneurial opportunities. Okay, so please, when you listen to me, listen from that perspective as to what can be an economic opportunity for you people. Okay. I would like the session to be interactive. At any point of time, if anybody has a question, please unmute yourself and you could interrupt me. For technical reasons, the presentation will be shared by Dr. Bhavani and I will do the talking from here. I hope we will not have any more technical glitches about that.
No, sir, don't worry.
Yeah, thank you. So, ma'am, can I just request that we run that small YouTube video so that people can visualize when we say what aeroponics is and what it could look like.
Sure, sir. Hema? Hema?
Yes, ma'am. Yes, ma'am. I'm just clicking on to the second slide. Yeah.
Or you could do a copy paste if there's a difference. Yes. This is a facility we have created. This would be the third version of the facility we have created actually. It all began with a small activity in one room. We had a second one which was slightly larger, and this is a much larger facility, a more sophisticated facility at a place called Davangere. I think you should do a control click.
Sir, can you send me the link in the chat box?
Sure, I'll do that. Okay, we'll come back to the link in a minute. Okay, just give me. We can move to the next slide. Okay, we'll come back to that video. Okay, so I took the liberty of including some more. I mean, first covering a little bit about the broader side of soilless methods. Okay, which includes hydroponics and aquaponics. So let's just look at the images. Next slide, please. Next, some 8-10 slides. I just have pictures, and I'll just take a minute on each. So this is something that people are attempting. I'm sure at many exhibitions you'll have seen such pot structures for growing strawberries. Okay, this they could call as vertical farming. In the pots, basically they have a coco peat and a media and a drip irrigation line running it, so that where you could have found 1 acre of land, you're actually doing say probably 5 or 6 acres of land. Next slide, please. Yeah, this is a simple one line, one pillar installation where you're growing multiple crops for your backyard or kitchen gardens. Next slide, please. Okay. This is a more Indian installation, I believe somewhere in Punjab. I've taken these from some of the hydroponics groups that we have. There's a little bag in which they have put, coco peat, and they're growing the household required vegetables. Next slide, please. Yeah, this is the family harvesting out the vegetables that are required in the apartment block. Okay, they have made different blocks with different vegetables so that their monthly requirement would come from there. Next slide, please. Dutch bucket system, they say, for growing cucumbers. Okay, the whole media is held in buckets, and there's a drip irrigation mechanism that gives fertilizers to the plant. Next slide, please. Yes. So these are more ambitious design plans. I'm sure if you just put this on Google, you'll get this image as well as the whole document. People are talking about doing vertical farms, vertical townships itself. Okay, in Bangalore, the Brigade Group has made an experiment on the airport road where they have a whole building that's covered with greenery like this. Okay, it's supposed to bring down the temperatures as well as increase the oxygen levels. Next slide, please. Yeah, now they're coming in with the shop-in-shop concepts where in the departmental store, you will have your live vegetable garden. You can go pick it up. Next slide, please. This is another technique where we call as NFT, nutrient film technology. What you're seeing is channels in which are placed in an A-frame. The A-frame basically gives you higher density of planting and basically avoids the problem of shading or shadow. Okay, so next slide, please. The nutrient flows as a film. This is a vertical farm again. This is at a farmer's field near Kolhapur. The blue container at the bottom, at the floor level, has the nutrient which gets pumped repeatedly from the top and falls down by gravity. Next slide, please. And this is a larger installation of the A-frame itself. Next slide. Yeah, this is what otherwise also is quite popular called deep water culture. Lettuce is being grown in standing water, nutrient water. Next slide. Yeah, there's another commercial installation for lettuce on bucket system in a different method. Next slide. Yeah, this is growing other larger vegetables. This is for brinjal. Next slide. Fodder grass for cattle feed. Okay, another very popular thing being supported by various state governments at various scales of practical usage by farmers. Very, very simple to build and highly effective. Next slide. Yeah, this is again deep water culture, but what I wanted you to look at is the background in the photograph where they use what we call today as a retractable rooftop greenhouses. For further information, just look at this cravo.com, cravo.com. Okay, this is a company that makes these structures where actually, unlike the other polyhouses, we know the whole roof moves. Okay, I'll come back to why this is important in a little while, but just notice that this is a different kind of environment in which hydroponics is practiced. Next slide, please. Same, this one, different batches. Next slide. Yeah, some people also use different lighting techniques. Lighting is a less understood, less documented intervention in controlled environment agriculture, but I just wanted you to have a visual of that. Next slide. Yeah, this is aquaponics. Some people, particularly in Bangalore, also have attempted this at large scale, but basically you have fish in an aquarium and the waste produced by the fish is used to fertilize crops. Largely laboratory oriented, but there are some commercial scale applications. Next slide. Yeah, this is again some research kind of mechanisms for this one. We must understand that while these all have been attempted, there's a fundamental phenomena that happens, which is geotropism and phototropism in the plants. You must factor for that when you design such equipment. Okay, we'll touch upon it in a while. Next slide, please. This is a household installation. You can do it. People grow something called as microgreens. It's healthy to eat sprouted seeds, and hence, different seeds are sprouted in this manner and served to you. We may have seen it at airports and some exclusive restaurants. Next slide, please. Yeah, this person's name is Vimal Kaul. He's a practicing farmer. To me, he's a guru, and he's dedicated his life to soilless cultivation. He's growing English cucumbers in this farm. Next slide, please. It's at Delhi. And he's very much accessible on Facebook. This is his farm where he's got a wonderful lettuce field in shade net house. Next slide. Yeah, this is him showing you the entire root mass and this one for strawberry. Next slide. You can catch up with him on Facebook. He's an excellent teacher. Capsicum available around Bangalore. Next slide, please. More common installation. This is one from Chennai, where the same NFT has been done very differently, but you'll notice that this is a single layer. Here, they are not attempted the A-frame. Yeah, the name of the person is Vimal Kaul, Vimal Kaul. So he's on Facebook. He's pretty active, open to share knowledge. Next. Thank you. Next.
Okay.
This is a little visualization of aeroponics. I'll come back to that. This is a photograph of one of the crops we have taken. You have a chamber in which nutrient is misted to the root system. Okay. Next slide. Yeah, this is the larger commercial installation where that visual image of a chamber you saw is basically a 1 square meter on the side surface, but on lengthwise, it almost goes for 30 meters length. And on the one side, we have windows which can be opened and you can access the root system. We grow potato crop. This is from our farm. Next slide, please. Yeah, and there's a little visual inside the chamber. You will see that we don't have 1 gram of soil. This is profuse rooting. That's what we do first. And then we initiate tuberization. I'll come to that in a little detail. Next slide, please. Yeah, this is one other installation we had done where you can see the potato microtubers coming there. You just open the window and you can put in your hand and harvest it. Okay, aeroponics, one of these most successful commercial applications of aeroponic science in business is really for potato production. There are more than 50 projects around the world for this. The idea is to get disease-free microtubers for farmers. Next slide, please. Yeah, this is the way the chamber would look across 30 meters length. Next slide. Yeah. So let's begin with this question. And my idea of sharing the visuals first to you is that students couldn't relate to what we are talking. Okay, when God has given us soil, why should we be looking at soil less cultivation? And I had to ask this profound question to myself before I went down this rabbit hole and lost myself for the last so many years. Because fundamentally, when we look at one perspective, farmer is not earning sufficient money for what he grows in the soil. If he has to grow it unnaturally in artificial conditions, etc., nobody is going to pay him anything extra. So is it necessary? Is it relevant to India? Not directly. I do not believe this is a technology for farmers for immediate usage. This is most relevant for countries where you have 5 months of snow, or you're located somewhere in Greenland or Canada or in Australia where access to food is difficult and climatic conditions are adverse to you. But otherwise, like in a country like India, okay, this is something that teaches you so many wonderful things which you would have never otherwise learned, particularly about natural resource called soil and water. God has given us so much abundance of soil and water that we abuse it and we take it for granted and we don't try to investigate it. And in my own journey, because I practice soil-less agriculture, I have the deepest respect for soil. It's such a wonderful natural creation that if you only set right, agriculture is the only subject. I repeat this at all my talks. Okay, only subject in which if I sowed one seed, I am supposed to get 100 seeds. That is the desire of universe. That's the desire of God. We are messing it around where we don't see that happen. Agriculture cannot be about poverty. It is about multiplication. One seed should give you 100 seeds. That's the law of nature. So I invite all of you people studying biotechnology and others to really look at more in terms of how do we understand this magic of nature? And I'll touch upon certain points. But most importantly, if all you youngsters were to learn this, quite like India exported software engineers to the world, I would see one day high-tech farmers being exported out of India. That's my dream. Next slide, please. So what makes aeroponics different from hydroponics and aquaponics and all other kinds of systems? Okay, now typically one big factor to reduce out when you work in soilless cultivation is the presence of a medium for cultivation. It could be water, it could be coco peat, it could be other rock wool or any other media. And in the case of aeroponics, we are very, very clearly choosing to have nothing there. Okay, and why we say so? Because the media itself has a role to play in the amount of nutrients it holds back to the crop. And a very important thing really is about the roots being sensitive to waterlogging conditions. So if you notice much of the photographs that I had of various forms of hydroponics and crops, mostly they were of lettuce. Okay, now that's only that much of leafy green vegetables will be eaten by human beings. When you're going to go through a complex crop, which has both a vegetative phase and a generative phase where there's a complete physiological change in the crop, you cannot have waterlogging in the roots. So we go for a zero growing media. Okay. Now, obviously, when you're doing this, there is some way the plant should be held suspended in the chamber. That collar with which the plant is held is a unique innovation in itself, because it should not suffocate the plant's growth. It should not choke the food and water flow through xylem phloem, and yet accommodate the growth and hold the plant firmly, not letting it slip. Okay. Now, the environment you create for the root chamber is very, very important. We'll touch upon this. In the video later, you will see there is a mechanism by which we spray the nutrients as a mist. The size of the spray is very important here. Okay. You cannot have big droplets sprayed onto water. They'll cause, under the roots, it'll cause injury. You cannot have too small droplets. It will never reach into the plant. Okay. And last but most important part for aeroponics, you literally need another polyhouse around it. You need a climate which is very sensitive, because if there is no power, if there is no proper environment, the plants will die very fast. Next slide, please. Yeah. So what makes the magic of aeroponics happen? One is really the increased amount of oxygen available to the root system. Typically in the soil, there is a barrier or a limitation to the amount of oxygen available to the roots. Hence, the root system needs to be provided by energy, ATP, as generated in the leaves and pumped down back to the root system to keep it alive. Whereas in this case, not doing that saves a lot of energy for the plant for its own requirement. Two, in the soil, or for that matter, any media, the nutrients basically consisting of anions and cations react with each other and become locked or unavailable to the plant system. Whereas in this case, that is not going to happen. So you use significantly lower amount of nutrients, and that means a lot. Next slide, please. Yeah, that visualization again, you can see engineering and mechanical wise, it looks very simple. Okay, it's like saying I see a Boeing aircraft and say that even I'll make an aircraft. But there is too many precision things inside that. But the principles are very simple. Okay, every person who's seen our facility has gone back and copied it, and that's the way it should go. They will learn and they'll correct the mistakes in that. Okay, next slide, please. Yeah. So what would be the advantage of aeroponics over hydroponics and other methods? Okay, one really is the amount of root damage that happens because of excess water or excess nutrients in the medium. Okay, the nutrient is not continuously misted to the roots. If I take the whole life of the plant, it's less than 1% or even point of the second decimal order. Next slide, next point, please. So the roots basically are not fighting for nutrition, and they're getting oxygen plus nutrients as required. Okay, the amount of nutrients that we use, which otherwise would be locked in the soil and taken away by other living organisms in the soil, does not happen here because it's a closed loop system. The excess nutrients that the plant didn't absorb is drained back to the reservoir and pumped again. In our case, we use less than 60 ml of water per plant per day. Next slide, please. Next point. Yeah. So basically, you have to really look at it in terms of how many people and human resources required. We don't so much look at this in India, but if you're in the Middle East or if you're in the US, this is one key thing of how much man hours it requires to take a whole crop. Next point. Yeah. So aeroponics is cost effective. There's a qualification, which is please don't use the capital investment required for such facilities. Capital investment very high, but if you look purely on operating cost basis and if you have a long-term perspective, it's an extremely affordable technology. There's nothing expensive about this. Next slide, please. Yeah, the visualization of the root I had earlier. This slide is crept in again. Next slide, please. Yeah. Now, if you had to compare a little about, growing in the soil, growing in hydroponics, and for the matter, some of these crops we can take, including potato in a total bioreactor in a tissue culture media, okay, versus aeroponics. Aeroponics is really versatile. That you have the presentation copy. I think you can share it around. I'll not read so much of it, but you can give a different treatment to the root zone and the shoot zone. You can create differential heating, cooling. You can continuously maintain a sterile environment to see that you are really altering only one factor at a time when you do research. Okay, if you wish to study crop physiology, this is the only holistic method. The role played by soil or medium does not happen here. Next slide, please. So because this is in controlled environment, you don't have to bother about insects and pests and disease. Of course, you have to maintain hygiene for that. This is one place where the buildup of chemicals doesn't happen, which could be poisonous to the crop, and hence is very, very safe because there's nowhere the nutrients can accumulate. Right, please. Next slide. Where could we use this for research? Because I really wish that all you students really begin with that and don't rush out saying there's money in that. See, the reason why you don't see so much of literature about aeroponics on the net is the world's largest application of aeroponics is in America to grow cannabis. And that's not required for this country, at least. The US people may want it, but at least in India, we don't need it. We need potato, we need turmeric, we need ginger, we need groundnut, we need many other medicinal plants. Let's begin with them. We haven't done adequate research in that, so I will touch on this. Any person trying to understand crop physiology, both biotic stresses and abiotic stresses. If you wanted to study symbiotic microorganisms for the root zone, what would I say? This is a technique to understand both susceptibility of plants to various pathogens as well as its affiliation to many beneficial microorganisms. Similarly, to understand, if I had to understand the stress of moisture and or sunlight and or any other factor, it's a great tool for us to be modeling and generating data. It will cut down research time in many, many years, which in field conditions would have taken a long time. Next point. Yeah, so studies on crop nutrition, that's very important because I think that's a subject that India did pioneering work about 40 years ago. All the NPK recommendations and all the micronutrient recommendations currently available are, by God's sake, very, very old. They are no longer relevant. Our soils are not the same. Our climate is not the same. We have very poor understanding of the forms of nitrogen the plant will take up. We give one standard form of urea because that is what government gives under subsidy, and we don't realize how we are damaging the soil around us. We use significant amount of muriate of potash. If you were to look at literature of what is exactly muriate of potash, it is potassium chloride. In the presence of water, it disassociates to become chlorine and potassium. While chlorine is a little nutrient, at a certain time, it's also disinfectant. It kills some other soil biology. If you had to understand these aspects, you need a technology like aeroponics. Okay, plant microbiome studies, these are of great interest today because we realize that including human body, there's a huge role for microorganisms around us which help us in many ways, both for human health as well as plant health. Okay, proteomics, metabolomics, these are very recent developments in science thanks to various instrumentation and cutting edge research happening. If you needed to study how these happen, you need a technique called aeroponics. So the interest for many people really are on phytonutrients. How can we enrich the presence of ashwagandha? Or for that matter, we have many medicinal plants in which we know there are different phytonutrients that are produced. How can I improve it by either altering a certain nutrient and or environmental conditions? Everybody knows that medicinal plants collected from forest contain more active ingredients than those synthetically cultivated. But that doesn't mean we go out and exploit our forests into the medicinal plants extinction. If you needed to understand and study these, aeroponics is a method to do it. One area that I did a lot of work, that's the last point on the slide, is induced systemic resistance. Okay, now if a plant were exposed to a simple molecule called chitosans or chiatins, okay, these induce in plant resistance to fungal pathogen infections. Now imagine it's like a vaccine to the plant against corona. Instead of spraying so much of fungicides and chemicals and polluting the environment, if I could just expose the plant to a little bit of vaccine, it will not get an infection. Isn't that wonderful? And all these are possible by working on aeroponics. Next slide, please. Yeah. So, like I said, today the largest commercial application is for production of seeds of potato. Also, people are working on crops like saffron and oil seeds. These are crops in which, frankly, you cannot store the seeds because you can plant only one season. And if you try to hold the seeds, basically the seed quality deteriorates over the holding period of the 1 year for the next season. And hence, this is our very strong feeling. If you are given good quality seeds to a farmer, half the battle is won. If you give him bad quality seeds and then give him subsidy and whatever other support chemicals, it makes no sense. If you give him good quality seeds, he's halfway through making his money. Okay. The other place where a lot of work is happening is in cultivation of medicinal plants. Okay, because we need medicinal plants out of which active ingredients are extracted, which are of high value, where we don't want any trace chemicals also, weedicides and herbicides or pesticides landing up there. Next slide, please. Yeah. So, yeah, I would just like to preempt some questions. Okay, deny you the opportunity, but I will leave it for discussion in a little while. Okay. Now, many people ask me these questions. Okay. Is aeroponics organic? Okay. I choose to reply saying depends for reason. Given a choice, I would like to think like a customer. And the customer has been confused by the use of word organic. Okay, where some purists say that no chemical fertilizer also should be used. Now, obviously, if I didn't provide nutrient, there's not going to be a crop. But the way we use it is absolutely safe, responsible, and probably the most technical and scientific. Okay, and we do not use any pesticides. So, in the spirit of organic word, it is organic. But in a certain reason, I never speak of aeroponics as being organic. For reason, I don't want to confuse the farmer between naturally grown food versus aeroponically grown food. Having said that, the next question that most people ask me is it safe to eat aeroponically grown food? And I would like to reassure anybody who has doubts, saying it's limited to 100%. Yeah. Some background noise. Yeah. So anything that the plant needs is provided just in the quantity that it requires. Because there's one beautiful thing when working with plants. Plants do not have any greed. Unlike human beings, if I like sweets, I'll eat more sugar, or if I like salt, I'll eat more salty things. If I like fried food, I'll eat more fatty oil foods. Plants don't behave like that. Unless you create an environment where you are exposing it to a certain metal, where there's a certain phenomena called bioaccumulation, it does not happen. Food is safe, because anything by you look, 70% of it was moisture. A good 28 balance percentage was carbon. Okay, so it's very safe to eat that. Is it natural? Yes, there's nothing synthetic about this. It is very natural food and is a natural plant. There is no genetic modification here. We are commercially practicing these things. You could get high yields here. Okay, again, I use the word depends, because what is the unit of measurement? Just so that as a reference you get, when I grow potato plant outside, I get 8 to 10 potatoes per plant. When I grow it in aeroponics, I'll get 25 to 50 potatoes per plant. Okay, here I'm not going to look at a whole plant weight. I'm going to look at number of tubers. Okay, so the scale of measurement is very important. Now, how much of less water and nutrient? I mean, I believe less than 2% of the water required for conventional agriculture. About, again, 0.5% of the fertilizer that you would otherwise use. That's all you need. Next slide, please. Yeah, so, I mean, to those people who are interested, one slide before the conclusion, please. Okay, don't rush in and do this aeroponics because Google and YouTube shows you some very copyable things. Okay, this is a deep science. You need to learn deep things. And hence, please do your homework and prepare and jump in. Okay, do small scale experiments. And when you do that, don't start writing an Excel sheet to see how much money I learn at that. You will make money on this only when you work on a very large scale. Okay, so the fact that you can make a cycle does not mean you can make a motorcycle. So if you do successful experiments in your balcony or in your lab, don't rush out and invest a lot of money. Okay, this will take you a little time before you have cracked the entire thing. Okay, now ask yourself that one question, which is this technology for me? Am I willing to dedicate 5, 7, 10 years of this before it's perfected? Then go to it. Okay, if you have an yes. If you have a no, if you're trying to make money fast, please go to real estate industry, go to stock market, go to software, you'll make money faster there. Next slide, please. Yeah, this is just this morning's photograph. Okay, this is the potatoes in the chamber. Next slide, please. Next slide. I think there's a video. Can we just click on it to run, please? No, on the previous slide, would it run? I think it'll take a moment to load. Let's see if it works. Okay, leave it. That's okay. We'll come back to the videos. I'll share the thing quickly, the link, and we can show this one. Till then, any questions, please? Yeah.
So thank you for the wonderful presentation. I have just one basic question, sir.
Yes, please.
You're working with potato seeds, and you said the yield is about 10 times.
Yes.
10 to 100 tubers of potatoes. I just
Yes.
have a is the reason that because you give minimal water, the rooting is profuse, and that is inducing the formation of tubers? One. And in which case, is there any difference in the yield with the harvest you get from the root and the shoot system? Hope you got my question.
Yeah. Yes, please. Yes, ma'am. So quickly, frankly, we can influence both the mass of root system and the shoot system. You know, that's literally playing God. And we selectively choose to do this to maximize the yield. Okay. Quite like in field, if you don't have adequate shoot system, you will not get an adequate yield. Okay. And similarly, if you let profuse rooting, you will not get a proportionate tuberization. Yeah. So it's a little skill and an art that we will develop over time. Okay, it's not going to come up just like that. Okay, that's the first part. Your earlier question, I'm sorry I missed that.
The increased number, is it because of profuse rooting, which I feel because you are giving minimum water, the plant should try to make use of the best water available, and so increase in number of roots may be one solution.
No. On the other hand, actually what happens, ma'am, is this. Couple of things happen. One, the plant really saves a lot of energy, which would have otherwise gone into keeping a root system alive. Okay, here that is available in the plant for later storage as tubers. It's only photosynthesis that is going to create the increased tuberization. Tuber crops have a little unique phenomena of source and sink, where it stores the photosynthate that it is created into the ground system. Okay, we need to understand that. This is not the same for all other crops, but tuber crops have this unique situation. Okay, the large number is basically because we don't let them grow into bigger tubers. See, in the soil, the problem really is I don't know what is the size of tuber forming below. Okay, so we wait till this one, and so one tuber becomes big and one becomes small, and so we get irregular shapes and sizes. Whereas here, by the time it achieves a size with which it is practical for the farmer, we take it away.
Okay, sir. Yeah. Thank you.
Thank you. Anybody else, please? I need to go through the chat. Just give me a moment. Some of you have posted, I think, the questions on that. Meanwhile, I have just sent to Dr. Bhavani the video link.
Okay, sir. Yes, sir, it has already come. Sherry, I am sending it to you. Sherry, are you there?
I ma'am.
Did you receive, ma? Just now I sent.
Yes, Bhavani ma'am.
So you are muted.
I'm sorry, I missed it. So I was just saying, I was replying to a little question about, can we do aeroponics in our apartment? Okay. Yes, it can be done. Okay. Please ensure that you have 24/7 power backup. It's very important that, the misting system to the root zone does not stop. In our experience, plant suffers permanent damage anywhere from a couple of minutes. Like I've seen 10 to 15 minutes is okay, but anything more than 10 minutes, that depends on certain parameters of temperature and other conditions there. The damage to root system is irreversible, at least in potato crop. So your power availability to the crop should be 100%. Okay, that is what makes it very expensive. For example, in our facility, we have a 230 kilowatt generator, which gives us continuous power to maintain a very large facility. Okay, otherwise there is no cost to other things, much cost to humans, cost or water cost or what I would say, soil preparation costs.
Sir, can we play the video?
Sure, please.
It says host disabling.
Yeah.
Sir, in the meanwhile, do you have any R&D lab, sir?
At the site itself, ma'am, we do have an R&D facility at the lab there. We used to have it 1 year Bangalore, but we consolidated all our operations into one location.
Oh. So if the students are interested, do you permit them to conduct any experiments, sir? Because as such to set up the aeroponics and work, that itself is a big task, no? Now, do you permit students?
No, it's a commercial facility, ma'am, but
Okay.
two things we'll do it for their learning. Okay, we can show them a live video session from there.
Okay.
To let us create a facility around Bangalore. We need one around Bangalore.
Okay. Okay, sir. Thank you.
Yeah. Because there we do commercial production. We have contracts with our clients.
And it's a very costly affair, no?
Yes. No, at the end of the day, frankly, ma'am, if you're not making money,
Exactly.
you're not working for farmers. See, profit, other things later.
Yeah. Sure.
These things should be intrinsically profitable.
Mm.
There is no audio, so just the video will run.
This is the Chikmagalur facility, sir?
Yeah, Davangere.
Davangere.
So we have about 9 acres of polyhouse completely. These are the aerophonic chambers. What you see below is like window frame is a place. The otherwise there is a holding frame for the plants, which are held actually by a string. Actually, the collar is held, not the plant. And of course, potato being a soft plant, it is entwined onto that there. I think buffering is taking time here.
So yours is the only one in India?
No, ma'am. Our nearest competitors are ITC, Pepsi, and Mahindra.
Oh.
So this technology is really held by top people as top business secret. Frankly, we believe in opening up science to everybody so that everybody can benefit. Okay. So though we have done a lot of work, we are open to sharing the sciences. Only then will new things emerge. This is how cold air is pumped to all the crop to maintain winter-like conditions. So the environment control is a very important part. A very simple thing you need to know is, beside the genetic factor which determines the yield of a crop, environment plays a very important role. Nutrient uptake is a function of the environment. Let's see the video and I'll just share one thought about it. So I was telling you that we need to maintain sterile conditions. So you have to pass through a disinfection media chamber, and the entire double door system, etc. are there. These are the boys harvesting out the potatoes. And the down, you can notice the two pipes there. This is a variety called Neelkant, which has a high antioxidant content in that variety of potato. I just shared one more video to Dr. Bhavani, which is this morning, this one. This is our tissue culture lab and cold store. And this is where we take up further multiplication. Question, please. So this is under insect-proof net house conditions. We further multiply the seeds to make it affordable to farmers. That's about the video. There's one more small clip. If it can be loaded, fine.
Sherry, I've just sent it, ma. You received it. Please check it up.
Yeah. Thank you. I see some questions. Marketing the aeroponics. So this is a question: how do we market the aeroponics? This one. See, for the seed. Sorry.
I'm an explainer speaking. How you are marketing these products?
Yeah, sir. Basically, we are very familiar with the seed industry. So there are seed multipliers based out of Punjab, and also we are working with some farmers in Ooty and in some parts of Karnataka, where winter conditions are available, because potato crop requires winter conditions. More importantly, it requires aphid-free zones where we don't have the insect that carries virus. Okay, so we need controlled conditions. We work only with such of those farmers who understand the seed plot technique as given by the Government of India Central Potato Research Institute, and they further multiply it as generation 1, 2, 3, and then give it to farmers. So there is a government protocol about how this should be done. We follow those procedures.
The physiology of the plant is studied, sir, using aeroponics. Now, like whatever we know about normal land plants, when it is grown under aeroponics, is there any parallel study to understand the physiology and the things?
Yes, a lot of people are doing it, ma'am, both to, particularly for proteomics.
Okay.
Okay, to understand ABA proteins response in the plant for moisture, stress, etc. Unfortunately, in India, still it is not popular because that includes us. We are part of the crime. We have not really marketed laboratory systems. We need small-scale equipment in which work can get done. But that really requires, because most pure science research happens at ICR institutions.
Now, since you have ignited the idea, I'm sure Chennaiites will take up, sir.
Okay, would be very happy, ma'am. Okay. Any other questions, please? Coming to a little bit of entrepreneurial thought, etc. Frankly, students, this is what I would say: be bold, okay, and experiment. You have a long life to live. This generation is more open to innovation.
Sir, do you think the plants are under germ-free conditions, sir? Just like nosocomial, this thing, not exposed to any natural flora. Now, when you grow under.
Ma'am, that's not the best descriptor to use in the sense, let's accept that there are a lot of airborne microorganisms which will settle on the plant. A unique biome is created, but generally what occurs in soil will not be present unless we externally introduce it.
So
and frankly, we have done
basically roots are under notobiotic condition.
Precisely. So we have done very limited work to see one place where they really do a lot of work, I know, is in producing of AMF,
okay,
vascular mycorrhizae.
Mycorrhiza, okay. Arbuscular
That cultivation is done. So these microorganisms that are endogenic to the root system, their multiplication is being done here in aeroponics.
Okay.
Because you get the root system and you get a lot of propagules in it.
I think Dr. Lakshmi Prasad lab at Vijayawada, they are doing, I think. That day he was presenting, no, sir, in your earlier
that talk. Yes, but he's still not using aeroponics, but they do other soilless cultivation.
Exactly.
No, given a choice, I would like to do natural farming with microorganisms to help the plant growth, etc. Okay, for reason of high productivity as well as what I would say uniqueness to potato crop. See, it takes 8 to 10 years to introduce a new variety. Okay, with aeroponics across the world, not just in India, and that's why Pepsi, ITC, Mahindra, and others have invested in this technology. Okay, in 2 years we can bring a new variety to the market. No, otherwise,
everyone is concentrating on potato?
Currently, yes, ma'am. Because respectively, ITC produces that bingo chips and Pepsi produces Lay's chips. And Mahindra wants to be in this entire space of farm machinery for potato crop.
Sir, taking all the trouble to get such good seeds only to add salt and spoil the product. It's not worth doing for Lays and other things, sir. Sorry.
No, I completely understand, but that's one of the reasons why we are working on that variety called Neelakant, okay, which is supposed to be high antioxidant. See, no matter what, the unique thing about India really is, India is the only country in the world where less than 20% of the potato is processed. 80% of the potato consumed is fresh potato.
Okay, good.
It is the fourth most important food to mankind.
Yes, sir.
Our per capita consumption still is not sufficient. If anybody had to Google with a little interest to see the amount of rich biodiversity available in potato as nutrition, which originates from Peru, okay, we can get a very wholesome food from potato.
Yes,
move away from wheat.
Yeah.
It's a good vegetable. It really alleviates poverty.
Yeah, even for children, they say no that and cooked potato and butter is a wonderful feed.
Absolutely, it's a very safe and good healthy food.
And tasty. Everybody likes it.
Absolutely. So what again people miss out really, ma'am, is the there are many varieties unique to each dish prepared. If you had to, there are specific varieties which are sugar free. There are specific varieties which are good for aloo paratha preparation where you need the no lump formation.
Okay. Smooth consistency. Okay.
Consistency and a flory structure. And it's like atta.
Oh.
Okay.
So you have varieties for specific dish also, sir?
Specific dish also, yes, very much. The samosa potatoes are very different. The aloo paratha varieties are different. Yeah. And this is a little thing that the trade knows. That's where they make money. And, they don't tell the farmers these things.
Okay. It's interesting, sir.
Rice potatoes are very good. Even for export also it is very nice.
That's right. I think India should be exporting potatoes to countries like Malaysia, Sri Lanka, and a whole lot of other countries neighboring to us. I do know a significant amount of potato goes to Sri Lanka from India.
In foreign countries, many of them like that red potato.
Yes.
Sir, excuse me, sir. Good evening, sir.
Good evening, ma'am.
Yes, I'm Jalen from Trichy, sir.
Yes, ma'am.
Sir, can you please suggest some of the institutes they are providing any internships regarding this hydroponics like that system, sir? Because the students are to be exposed like this kind of techniques, so that they'll be an entrepreneur, so that they can earn on its own.
Sure. So one is, I mean, just very recently at Institute of Horticulture Research, IHR, there was a workshop. Okay, they do conduct. IHR can, being a public institution, will respond when other colleges and institutions make a request. Okay. Which other ICR institution can I tell you, people? Central Potato Research Institute at Shimla, CPRI Shimla, they formally transfer this technology and showcase and provide opportunities to students.
Okay.
I'm not sure if they will let a student do research because they're a little protective of the kind of work they're doing.
Yes.
Okay, but they will definitely showcase and give the technology on license. They take a small fee and they give it to interested parties. Okay. Around Bangalore and Hyderabad, I know at least some 25 to 30 people do these projects where they're willing to showcase. But please, my request to both the institution as well as students really are, don't get carried away by lettuce. There are not going to be many people who eat lettuce.
Eat lettuce, yes.
Okay, not that I have any problem with it. In fact, I enjoy lettuce. The two issues. One, Indians don't follow any post-harvest practices for lettuce. You know, a lettuce is a wonderful thing which you should really cool it down significantly after harvest. Indians don't do it. Second, you're only growing the crop for vegetative phase. It's a 1 month crop, very easy to grow. When you start growing other crops where you need to work with phosphorus and potash is when you will get into difficulties of growing the full crop cycle where you have crop to harvest. Not many people will.
So yes, you think any indigenous model of
the line dropped, ma'am. Indigenous technology of aeroponics. Hello.
No, indigenous model of aeroponics setup or unit to simulate the conditions so that it can be handled by anyone and take care of the various conduct research studies.
Maybe I'm really seriously considering making up these things, ma'am, as a size of a table, a school student table. Okay, just give us 6 months. Okay, we will put out such equipment in public domain.
Very good.
Because actually there isn't very complicated, but some precision components are required. You know, which is what we haven't rushed out to do it. Two things are important. One is you should have access to good quality water, which is low EC and neutral pH. Okay, and you should have 24/7 power backup.
We can make use of the sun, sir. Sun is there to give as much of energy as we want. Solar cells.
Completely agreed. Completely agreed to that. That's where we need to do a little work because only recently we are getting DC pumps. Otherwise, we go through a little bit of electrical engineering where we convert solar DC power into AC power and then run pumps. Because the pump is the heart of the system. And there's a little electronic circuit that controls the frequency of sprays. Too excess is a waste. Too less will lead to stress to the crop. Like we follow a protocol where for 10 seconds only we miss the roots and we do it every 10 minutes or 3 minutes, depending on the stage of growth.
Okay. Sir, which these challenges are taken up by the engineering students, no? Like
yes.
And
yes,
wonders can happen, no? Because our Indian brains, no?
Absolutely. Because at the end of the day, ma'am, it's just a simple dabba with one electronic timer and a pump. But the essence really is in the crop nutrition, ma'am. While all this engineering can get replicated easily, most people know what happens is plants are very forgiving. So even with bad nutrition, you'll get a crop, which is what I see with many people who experiment with hydroponics. Okay, the years go before they know that they're not giving full nutrition. It's like how many children we have on the streets with malnutrition.
Yes, sir.
Okay, so so with a little bit of work and number of cycles, we start understanding why the crop health is improving. Now, quite like we can't define human health, we can define human disease. Like that, in a crop, we have a difficulty in defining what is a good quality crop. But potato, a lot of work has happened, be it Central Potato Research Institute or the International Potato Center, or like I said, there are at least 50 projects around the world. Okay, so there is a very good, healthy interaction and development happening there. Because you cannot do a bad work and get away with it.
Yes, sir. Thank you.
So that last video, could we run it? They will see this one, but not essential otherwise. And please share the presentation and the links to the students. Somebody was asking if they can have a copy of it.
Have you shared the link in the group, sir?
Please go ahead, sir.
It is there, the group link, this video.
Yes, sir, it is there.
The link, I have not seen that. If it is there, the link, I can even play it if at all.
I will just mark it also, sir.
If it is in the link, I can play it immediately.
Hema, any problem with the second video, ma'am?
Second video, ma'am. I just, whatever you, Sherry ma'am sent, it was played, ma'am.
No, I sent a second one. First one was already played. Second one, did you read? I think you have seen it also. That's what my cell says.
I didn't receive.
Just marking it to
No, Sherry has seen it.
Okay, because the Sherry ma'am had sent me, she didn't say anything, ma'am. So the first video I had shared, the second video I didn't receive.
You can share it to the students later also, please. Okay, doesn't
Madam, can you share this in the box now, that the message box?
Yes, sir. In this chat, is it? In this chat,
the message box, I will do it immediately. I'll share it.
Shall I send it to you, sir?
Yeah, you can send to the message box, madam. The box.
Yeah. No, message box I do not know how to send.
Okay.
I will send to you, sir.
In the Zoom chat. Sir is asking whether it can be posted in the Zoom chat, ma'am. Zoom meet chat box.
No, if I disturb, I don't want to miss out on the thing.
This is the potato thing, right? Isn't it?
Yes, sir. Yes, sir. This is the second one what I received from Mr. Jagadeesh.
So I need this screen sharing option.
Hema.
I think.
Hema will do it.
Yeah.
I think from Sherry to everyone. We can all see together on the screen, Sherry.
No, I don't know if in a chat you can send the video.
I got it, sir. The thing is, the only thing I need is sharing option. If I get the sharing option, then it's been. I mean, Dr. Hema is the host now. She has
Hema,
to.
you are able to hear Dr. Seshadrima?
Yes, sir. 1 minute.
Yeah.
Yes. It's a very short video only.
Sir, any work on symbiotic relation? This thing, sir?
AMS people are working, and I know that there is one team at IRI working on Pseudomonas fluorescens. Okay, those varieties as more as a biofertilizer rather than a biopesticide.
Oh, no, I'm asking about the rhizobium legumes.
No, nobody is working on nitrogen fixing bacteria and P solvizing bacteria.
Okay, sir.
But it's a greenfield area, ma'am. Lots of students can take research.
That's a lot of scope for research, sir.
Yeah.
You are telling about chitosan, even that is an interesting problem, no? Like to see the increase.
Sir, you are the host now. You can present, sir.
Seshadri, sir.
Yes, madam. I'll run it now. Yeah, it is there. So yeah, I hope the video is visible now.
Yes, sir.
Now I'm running it.
No, there's one more sent. This is the same morning with you.
Uh-huh.
Sir, I sent it to you on
This
WhatsApp.
I had presented, sir. This I had presented.
Oh, then the other one, I'm sorry. Okay. I think I have given the wrong one.
Oh,
I
Shisha,
thought
I sent you on WhatsApp. I sent you the second video also on
Yes,
WhatsApp.
sir. No, maybe I thought I had sent.
Yeah, this is the one.
Sir, did you receive the second one, sir? Sesha,
yes, sir. Now I got it, madam. Now I got
Yeah.
it.
The one above.
I try to open
Not
this.
this. The one above it. Not this. This is again the one above this, sir.
Yeah, this we had presented. Yes.
Is this the one, sir? No, this one?
That's the one. Yes.
Yes.
Oh, you could see that now?
Yeah. This is what I sent. Yeah.
This is today's crop where they were going to undertake harvest.
Yeah.
Now with the development in technology, with the physiological, molecular level, things can actually, they can do wonders, sir.
Absolutely. No, I wish to see a world where we use lesser chemicals. There is no need to use and waste so much fertilizers and nutrients and water that we do. So at the end of all this work, I would like us to be closer to nature.
There is a problem in sharing.
You can share that video to the students, sir. Only whatever. Let them use it for their learning purpose. That's all.
Sherry, students have any questions, ma? Hey, ma?
Students, if you have any queries, you can kindly post or you can unmute and you can talk.
In spite of your busy schedule, we are so thankful that we are able to listen to your presentation, sir. Thank you so much.
Ma'am, I mean, anything for students. Today is an auspicious day also for.
Yeah. Vasant Panchami.
This is my payback to my teachers. Somebody was kind enough to teach me these things. I was not born with any of this knowledge. So it's my duty to pass it on to the next generation.
Actually, WCC believes in lighted to lighten, sir. That's our motto, college motto, WCC.
Sherry, ma'am?
Yes, Hema. Yeah.
Please find out if students have any questions, Sherry, because they won't get this chance again. Now, having got him now, today they can clarify.
Ma'am, there are no more questions.
Ma'am, no more queries.
No more. Yes, ma'am. Okay. So, yes, ma'am. There are no more questions in the chat box. So, may I request Swarna to propose the vote of thanks. Swarna?
Yes, ma'am. Can you hear me?
Yes, we can hear you.
Yes.
Yes, ma'am. On behalf of the Center for Environment Studies in Indigenous and Frontier Technology Research Center, I extend a big thank you to our speaker, Mr. Jagadeesh Sunkad, for giving such an insightful talk on aeroponics. Sir, your talk has given us a really novel concept to ponder over in the coming days. I would also like to thank Ms. Bhavani for giving such a lovely introduction about our speaker, Dr. Sherry David, Dean of Environmental Studies, WCC, Ms. Ashita Chandran, Staff Coordinator for the WWF Program, WCC, Ms. Anjali Rahel, Staff Coordinator, Center for Environmental Studies, WCC, Dr. Hema Shankari, and Mr. Sridhar, IFTR, for coordinating the event so thoroughly. My gratitude to all the speakers for gracing the occasion and sharing their opinions today. We also thank all the faculty and students of Lady Robe College, Madurai and Stella Maris College, Chennai for having taken the effort to attend the webinar. And finally, I thank all the students of WCC who took time to attend the webinar and making this event a great success. Thank you. And before you exit the meet, please take a few minutes to fill in the feedback form.
Thank you, Dr. Sheshadri. Thank you, Dr. Bhavani. Thank you, Dr. Shankari. I wouldn't remember all the names.
Thank you so much, sir. Thank you so much.
Thank you so much, sir.
It was nice hearing you.
It's an honor. Thank you, sir. Can I exit the meeting? You can spend some of the
sure. Thank you so much, sir. Thank you.
Thank you, ma'am. Thank you.
Thank you.
Thank you so much, sir. It was a very good presentation.
Thank you, everyone at WCC, ma. You did a great job.
Thank you, ma'am. Thank you, ma'am.
Your great leadership. Thank you.
Thank you, ma'am.
Hope we'll be able to meet again sometime. Dr. Seshadri, sir, along with WCC, will have more programs.
Thank you, madam. Sure, madam. It's all because of you only. It's everything is happening.
No. Sherry, sir. Sherry did wonders. Actually, they are at the end of the semester. We'll have hectic time in WCC. In spite of that, no, she does things and she made sure that my laziness is gone. Hopefully, it is not reversed, Sherry. Thank you so much, ma. Thank you, Hema. Bye-bye. Take care.
Thank you, ma'am.
Shall I leave, madam? Or
Yes, sir. All of us, yeah. Thank you, sir. Bye-bye.
bye.
Thank you, ma'am. Thank you.
I am only leaving the meeting. I am not ending the
right,
meeting.
Sir? Yeah, thank you, sir.
Shall I end the meeting for all?
Yes, sir. Recording will be with you, right, sir? It will be in the cloud, right, sir?
Yeah, it is there in the cloud, madam.
Okay, sir. Thank you, sir. Thank you.
you.
Sherry, ma'am? Yeah. Yes, sir. You can end. Participants can leave the meet.
Yep.
Sherry, ma'am?
Please fill out the feedback form. Make sure you fill the feedback form before you leave.
Most of them had went, Anjali.
Yes, ma'am. They received 95 responses, ma'am. I think everyone has, yeah.
Okay, they would have, yes.
Yeah.
So, Sherry, ma'am, shall we leave Sherry, ma'am?
I think ma'am's network is problem.
So, shall we leave? So, sir is going to end up the. Thank you,
Yes,
sir.
ma'am.
Thank you, sir.